Hi, welcome back. This is the part 2 video for section 1.4. So we're going to pick up on number 12 where we left off from part 1. Example 12 is just a good example of thinking about what's happening on the left and right of a function before you find the limit. Okay, so if you look at these three questions, they're basically the same exact function. It's just that, remember, in order to find the limit, the actual limit as x approaches -8 of this function, we have to look at what's happening on the left side of -8 and the right side of -8. Okay, so typically, later on sections when we're doing limits, remember, even though you just get this problem, if I didn't give you these two first, I still, if I'm going to find the limit as x approaches -8 of this function, I still have to check what's happening on the left and the right side. Okay, unless I can do direct substitution. If I can do direct substitution and I get an answer, remember that that is the answer, and then I don't have to do anything from the left and the right. Okay, all right, so if I'm looking at absolute value, this is I'm pretty sure you're going to see this on WebWorks, but when you're doing absolute value, just kind of remember the rules for that. When you take the absolute value of any function, the answer you're going to get is going to be positive. Okay, even if you put a negative number in here, the absolute value of this denominator will always be a positive value. The numerator, however, will not. Okay, this is not absolute value, so I can get positive or negative values. All right, so when I look at this, I don't want to put in numbers like numbers getting close to -8 from the left, -8.1, -8.01, and so forth, and try to do this on paper. So algebraically, you could do this, but that's probably not going to be the best thing. And by the way, if I just did direct substitution and I plugged in -8, okay, remember you always want to check that, but if I plug in -8, 5 times -8 is -40, and -40 plus 40 is 0. So I would get, I'm going to put that over here, 0 in the numerator. And if I put -8 in the bottom, -8 plus 8 is 0. Absolute value of 0 is 0. So remember what that tells you. This is the indeterminate form, so that means you will get an answer. Okay? So I have to figure out what to do. So in this problem, I would suggest either graphing it or going to your table and doing a t-bar table and seeing what happens as your values get closer and closer to -8. One of the things, if I do look at it, I just want to remind you, okay, if I want to factor a 5 out of the top and get my x plus 8 up there, this might help us just see. I just want you to kind of see what's going to happen on the graph. Okay, so let me look at the graph real quick, and then we'll talk about our values. All right, so if you're going to do this with me, I'm going to put in the original function, just it's a little bit easier to do that on my calculator. So in the numerator, I'm going to put parentheses around 5x plus 40, close my parentheses, and then divide it by, and I just want to do this with you because in case you forget where your absolute value signs are, go to math, okay, and go over to, hang on a minute, sorry guys, battery is getting a little low, so let me plug that in real quick. Okay. All right, so on the math function, you go over to num, and it's the very first one, absolute value. Okay, so then I'm going to put in x plus 8, and then arrow out of the absolute value signs. All right, so now if I look at the graph, and I'm just going to do zoom 6 to go back to my standard 10 by 10 window, because I don't know what I graphed before. All right, and remember, I know the split is happening at -8, okay? Because if I put in numbers bigger than -8, this is always going to be a positive number. And if I put in numbers less than -8, this will still be positive, but up here I'm going to get negative numbers. So that's why I have this jump. Absolute values kind of always have some kind of a jump in it when you're doing functions like this. So we can see, if we count 1, 2, 3, 4, 5, 6, 7, 8. So at -8, there's the problem. Okay. So if I put in numbers to the left of -8, which is what I'm doing right now, that would be down here. And then if I put in numbers for this one to the right of -8, that would be these values up here. Notice they're all the same. And that's why I factored this out for you, because I want you to see that x plus 8 over x plus 8, whatever the value is, these are going to cancel out and give me 1, right? I'm going to cancel those out. The difference is that if I'm on the left side and I cancel these, one of these is going to be negative over a positive. Same number, but it'll be a positive number over, a negative number over a positive number. So that's why it's a -5 down here, okay? All right, if we go to the table, the other way we talked about doing this is making you a table, and let's pick numbers that are getting close to -8 from the left. So that would be -10, -9, -8.5, but we want to get as close as we can. So -8.1, -8.01, oops, 01, -8.001, right? Get closer and closer to -8 from the left. So I'm going to go to the table, and just to remind you, okay, I want to put in these numbers, so I'm going to go to table set first, so second table set, and make sure that you have your independent variable on ask. This way, when you go to the table, you will enter the values you want. So second table, remember, if you have numbers there from before, just hit the delete key and it'll delete them. So like if I had other numbers in here, okay, I would just go at the top and hit delete and get rid of that. All right, so now I can put in these numbers, -8.1. Notice I get -5, -8.01, -8.001, right? So that's that solid line, that horizontal line that we just saw going down at -5. So all of these are -5. Now remember, if I used 8, I got 0 over 0, right? So I would get, so if I just put in -8 right here, I'm going to get an error message. Can't have 0 in the denominator, okay? But I'm getting really, really close to that. So even though on the graph, okay, you can't see it, but there should be like little open circles here, right? Because there is no value at -8. So it's hard on your calculator to see open circles, but if I was going to graph this, then that's what I would show, okay? All right, now, from the right, coming this way, so I approach -8 from the right side, all my values are up here at +5, okay? So again, same thing. If I look at my table, go back to my table, pick numbers that are getting close to -8 from the right side. So let me delete those. Obviously, we see what we're going to get on the graph, but I would pick numbers like -7.9, -7.99. Right? Numbers to the right of -8 would be -5, -6, -7, and I want to get as close as I can to -8, so I'm going to use decimals. So if I put in -7.9, I get +5, -7.99, right, and so on and so on. So these are all going to give me 5, as I did see from the graph. Okay. So again, if I looked at this graph, here's -8, here's 5. So up here to the right, all my values are up here at 5. And then here's -5 down here. Anything less than -8 went to the left, okay? So this is what the graph would look like on my calculator, but again, those open circles, because at -8 there was no value, no function value. All right, so I can easily see that from the left and from the right, the limits are not approaching the same value. So your answer to that bottom question would be does not exist, okay? There is no limit at -8. We're not getting close to the same value on each side. Okay, so a little bit of time on that one, but just want to make sure you were okay on that. All right, so let's jump to number 13. This would be another one of these problems where I would say you're going to use your calculator and either do the table or a graph of some sort. Okay? All right. Remember the first rule of thumb, plug it in. So this is a trig function. Okay? So I just want to remind you what we're doing with the trig function. So we've got the tangent of 5 times x over the sine of 6 times x. Well, first off, if I was going to do this algebraically, I've got to know some pretty good trig properties in order to do this, because I can't cancel, I can't do anything if the argument inside, the angles inside are not the same. So I'd have to do a lot of manipulating for this problem. You know, typically if you guys have a really hard trig function that's a limit problem, most of you are going to go to your calculators because we just don't work with them enough to know what those look like and how they work. It is possible to do this algebraically, but again, for time, I'm going to just look at the graph and the table. That's probably what most of you would do. And again, you know, this is just practicing limits. We just want you to understand, you know, you're looking at left and right values and trying to find the limit as x approaches a value. So in this problem, it's simply x approaches 0. So that doesn't mean I just get to plug it in and do it. I have to look at the left and the right. Now if I did plug it in, let's talk about that. The tangent of 5 times 0, if I'm plugging in the value, you know, the direct substitution, okay, and the sine of 6 times 0, 5 times 0 is 0, so I need to know the tangent is 0, and 6 times 0 is 0, so I need to know the sine of 0. So if I look at my unit circle, that's the very first point on there is 0, and remember the ordered pair for 0 is 1, 0. Remember the x-coordinate is the cosine, the y-coordinate is the sine, and the tangent of any function, remember, is y over x. Right? So it would be this number over this number. So let's direct substitute and see what happens. So the tangent of 0 would be 0 divided by 1, right? Y over x. 0 divided by 1 is 0. The sine of 0 is the y-coordinate, and that is also 0. So remember what that tells you. That means you're going to get an answer. It's just I got to figure it out a different way. Okay? All right. So I need to look at the limit from the left and the limit from the right, see if I get the same value, and then I know if I have a limit or not. So I'm going to do the limit as x approaches 0 from the left of the tangent of 5x over the sine of 6x. And I'm going to do the limit as x approaches 0 from the right of the tangent of 5x over the sine of 6x. Okay? That's what I got to look at. All right, so we're going to look at the graph in a minute, but we're going to do the t-bar table, and let's just pick some values. So I need to get close to 0 from the left. So that's negative 0.1, negative 0.001. Right, get closer and closer. So negative 0.1, negative 0.01, negative 0.001, and so forth. And then on the right-hand side, getting close to 0 on the right would be the positives of that, right? 0.1, 0.01, 0.001, and so forth. All right, so let's go to the calculator, and let's look at this. Clear out my old one, and I'm going to put in the tangent of 5x. Let me just check my mode real quick. I want to be in radians, so I am. All right, so I want to do the tangent of 5x divided by the sine of 6x. Okay. Now I don't want to hit graph, because if I graph on this 10 by 10 window, it's going to be it's going to take a while for the calculator to do that. So I'm just going to go to window real quick, and I want to change my x min and x max. Well, let's just do negative 1 for my min and positive 1 for my max. And for y, let's do the same thing. And again, you're just watching, that's fine. But if I left it at 10, it would just take a really long time to graph it. Trig functions sometimes go crazy. So I just want to do this a little bit quicker. So I'm going to hit graph. So this is 1 up here, and this is -1. That's -1. And why isn't it graphing? Oh, what happened? I deleted it somehow. Well, that was good. Alright, let me do the tangent of 5x divided by the sine of 6x. There we go. Alright, so remember, this is 1 up here. One of the things that, when you graph, at least I know this is going to have a limit, because if I look at 0, so if I'm approaching this function from the left, that means I'm going to be coming this way. And if I approach 0 from the right, that means I'm going to be coming this way. So both the left and the right are approaching the same value, okay? So I need to find that value. Now, I can't just plug in 0, because remember when I plugged in 0, I got 0 over 0. But there is a limit, okay? Again, that's a different thing than the function value. That's real important for you guys to know that. So I could trace, okay? I could hit trace and try to find that. That's fine, but you guys got to remember, and I'll say this a lot, and if I'm helping you with WebWorks, you need to be exact. You can't put in a number in WebWorks that's close. For example, 1/3, you can put in 1 divided by 3, and that's perfect. But if you put in 0.3, WebWorks will mark that wrong, because 0.3 is not 1/3. Okay? You can put in 0.3, 0.33. That's not going to be enough. So WebWorks will mark you wrong if you round at all. So we need to find this exact value. Okay, so I'm going to go to the table and do that. So we could get close to the right answer by tracing this, but we need it exact for WebWorks. So table, I'm going to clear out those. All right, so I'm going to put in -0.1, -0.01, -0.001. Okay, and you can see your values are getting close to 0.833. I think I'm going to do one more, -0.001. Oh, one more 0. All right, so I can feel pretty confident that my value is getting close to 0.8333, right? So I'm going to write those in here real quick. 96752, 0.83453, 0.83335, and then that last one I did. So I can pretty much 99% say that this is going to get closer and closer to that. So that's a repeating decimal. And repeating decimals can be written as fractions. Okay, so I can figure that out. Now, I just need to make sure, but I know from looking at the graph that the positive numbers are going towards the same thing. So I'm going to go back up here. Let me just get rid of that so it's not so confusing. So if I do 0.1, 0.01, 0.001, 0.0001. Notice I get the exact same values, which I could see from the graph that they were both heading towards that. So I'm not going to rewrite all those numbers here, but I'm getting close to that same value, right? So I'm going to go back on my calculator and just go to the home screen and type in point. Oh, that's what I did. I didn't type it in y equals before, so I typed 0.83333. Type a bunch of them. All right, and then I want to change that back to a fraction. So I go to math, go to number 1, hit enter, and I get 5/6. Okay? So I know that the limit is going to 5/6. And look at that. Trig functions always have all these nice properties, but I didn't know that going into this. But notice I ended up with 5/6. It doesn't always work, so you can't just, you can't always assume that on a trig function. But the table proved that that was right. So what was the limit of our problem? The limit from the left and the right were both 5/6. So that means the limit as x approaches 0 of the tangent of 5x over the sine of 6x is 5/6. Okay, I proved that. So that's the answer. Okay? All right. Okay, so that's the end of the notes that you have in the guided notebook. Now, I added on the page for section 1.4 another set of notes, 1 page, 4 more problems. So I hope that you printed those out because they're graphs. It's a little bit easier to do if you printed it out. If not, you can do the sketches on notebook paper, which is fine, but I'm going to go through those 4 problems with you now because I find that a lot of times in your homework on WebWorks, it's really hard to do graphing problems, right? It's really hard to do that on a computer. So I always like to do these sketches with you because sketching limit problems is a real good way to make sure you understand what you're doing. So I just have a few of these. We're just going to go through them together because if you can create the sketch, then you do understand what's going on with the limits. You know what you're looking at, okay? All right, so for each problem, it doesn't really matter how you start. I usually always like to start with the function value, but you don't have to. It'll come out the same both ways. So I'm just going to do the first one way, and I'll do the number 15 the other way, just so you can see. So I'm always looking at problems. Do they give me a function value, or is it a limit problem? Okay. So this is a function value. It's just a point on the graph, 0, 1. So you always can plot those. All right, now the limits, when you have a limit and you're asked to graph it, always teach students to graph this ordered pair. This is still an ordered pair, 0, -1, but because it's a limit, it's going to be approaching that. It's not going to equal that. So I'm going to do an open circle. So go to 0, -1, and put an open circle. And this says, as my pen approaches this point from the left, I'm going to be approaching there, right? -1. So you can do it any way you want to. I just know that as I approach this graph from the left side, I'm approaching -1. Okay? So this is the limit as x approaches 0 from the left is coming towards -1. Okay? The function value is not -1. The function value is 1, but the limit as I come from the left is. You can do whatever you want over here, okay? This can go up, it can down, you can put an arrow, doesn't really matter. I don't know what else, that's all I know. And then I'm going to do the same thing from 0 from the right. So I need to be approaching 2. So that's a ordered pair, but open circle, 0, 2. And my pen, as I'm approaching this point from the right side, this is where I need to be approaching. So again, it can come from anywhere. It can come from down here, as long as I'm approaching and getting close to 2. Okay, so that's one example. So your graph might look a little different than that. It just depends on where you saw it. But what has to be true is like right in here. I have to see the pen coming in here. I have to see a pen coming in here. It could come from this way. Doesn't matter. Just has to have that set up. All right, so let's look at number 15. This one I did the function values first. Let's say I do the limits first. It doesn't really matter. Limits are open circles. So I'm going to go to 0, 1 and put an open circle. And this says the limit as x approaches 0. So what does that mean? Both sides are going to approach 1. So because I have other limits here, I don't want to make my lines so long. I knew this was the only limit, so I kind of did that. So what I'm going to do here is on both sides of 1, from the left and the right, I have to be approaching that. So I'm just going to do that because I don't know what else is going on yet. Okay? Now, my next limit is only 3 from the left, but that's still an open circle. So 3, -1 will be an ordered pair. 1, 2, 3, -1. And from the left side, that's where I'm going to be approaching, this side. So from this side, I got to be approaching there. Well, now I know that I got to approach here on the right, because remember, I have to approach 0 on both sides. I got to get close to 1. So this is actually going to go here. So that's really not there. Okay? All right. Now, 3 from the right side, so on this side of 3, I'm going to be approaching 2. So that's an ordered pair, but a whole. So 3, 2. And now we'll be approaching this value from the right side of 3. So from over here. Okay? Alright, so now I can make this tail longer if I want. I don't know what's happening, but all I know, so let's look at that. So from 0 from the left, I'm approaching 1. 0 from the right, I'm approaching 1. That's what that says, so that's right. 3 from the left, I'm approaching -1. And then 3 from the right, I'm approaching 2. Okay, so now I can make that a little longer if I want. So there's a graph that includes all of this. Okay. All right, typically you're given the graph and you find the limits, but if you can do this, this is a really good practice to make sure that you understand limits. All right, so pretty easy. Open circles at the limits, draw your little tails, and then put your function values in. Oop, I forgot my function values here. So f of 0 is 4. 2. So there's the function value. Has nothing to do with the limit. And f of 3 is 1. Has nothing to do with the limits. Okay, so those are function values. Okay, so limits may or may not approach that. I just don't know. Okay, let's do 16 then. So the limit as x approaches -2 from both sides, there's no plus or minus there, is 2. So we're going to put the point -2, 2. 2, 1, 2. Open circle. And I know that both sides are approaching that. Okay. Again, I don't know what's going on yet, so don't put big long ones. I just know from the left and the right I got to be approaching this value. All right, let's go to the next limit, 3. So 3, 4. 1, 2, 3, 1, 2, 3, 4, open circle. All right, now this says just from the left, I'm going to be approaching this number. That's this side. Okay, so now I know I could connect these. So as I approach 3 from the left, I'm getting close to 4. And as I approach -2 from the right, I'm getting close to 2. Okay, and that's what those two things say. All right, and lastly is 3 from the right. So I'm going to put that ordered pair as a whole. So 3, -2 down here. Okay, from the right side, I got to be approaching this. So from this side of the graph, I need to be approaching that. So just whichever way you want to go. Okay, so from the right, I'm approaching -2. From the left, I'm approaching 4. That's what these said. And on both sides of -2, I'm approaching 2. So now I can make this a little longer, can do whatever it wants. Okay, and then I've got my function values. F of 3 is 3. Now, I'm going to change this because all of these are not the function values, aren't the limits, but let's just say, I'm going to change this. So on your paper, change this problem to f of -2 is 2. Okay? Because I want you to understand that you may or may not cover up one of these open circles. So if the function value happens to be the open circle, well, then now that's an ordered pair. So now I would plug that in. So now the function value and the limits are both the same. Okay, that can happen. So but what you guys need to understand is, you have to go with what's given to you as a function value, what's given to you as a limit. Okay. All right, last one. F of 0, I'm sorry, the limit as x approaches 0 from the left is 2. So 0, 2, open circle. And from the left, so I'm just going to do a little bit because I don't know what else is going on. 0 from the right approaches 0. So 0, 0 from the right. So just put a little tail there for a minute. So from the right side, I got to be coming here. Limit as x approaches 4 from the left is 3. So 4, 3. 4, 1, 2, 3. So from the left. And then the limit as x approaches 4 from the right is 0. So 4, 0. Right side would be here. Okay, so now I can connect my dots. So this side is the end of the graph, so I don't know what's going on over there. These two will be connected. And then this is the end over here, so it can go up or down, doesn't really matter. And then I'm going to do my function value, 0, 2. Okay, 0, 2. Notice, uh-oh, that was 3, wasn't it? Ah! Okay, let's change that. Can't erase a pen, so alright, let's make f of 0, 3. Oh, wait a minute. I am going crazy today. Sorry guys, that was 2. I looked fast and I thought that was up at 3. Alright, so that is 1, 2. Sorry about that. So f of 0 is 2, actually covered up this hole. Sorry about that. And then f of 4 is 1. Let's see if I can plot that correctly. There we go. Alright, so this one actually was a limit from the left. That was the same. And this one was not. Didn't match up with either limit. But again, that has no rhyme or reason. Limits are different than those function values. So again, just kind of good practice. Okay? Alright, so hopefully that helps your understanding more of these limits. So make sure you're working on WebWorks. Please let me know if you need help. Reach out for the tutors if you need help. But you need to have a good understanding of this before we move forward. So keep working hard, and I'll see you back here next time.